Okay, 5-4, day 2. Get down here. All right, we are going to be doing the exact same thing we did on your quiz back in 5-3, except the distribution is going to be the sampling distribution instead of the population distribution. So you people that are going to take the quiz, you're going to get some help in this section. So Kenley, if you were paying attention, that would be good. So we are going to be finding probabilities when taking samples greater than 1. From a population. Okay, last time we were only picking 1 from a population on the quiz. Now we're going to be taking more than 1. So just like before, we're going to have to convert our x value into a z-score so we can feed it into the NCDF. Because remember, NCDF, you have to feed z-scores. So let me give you that formula first. Okay. Okay. So the z-score for an x value, but this time our x value is going to be a mean, an average, because I'm going to be taking more than 1. Say I take a sample of 10. I'm going to average those 10 together and get one number, an average, and I want to turn that average into a z-score. Is that better? The z-score formula, just like before when we had our 1x value we want to turn into a z-score, I'm going to take this one mean value, subtract the population mean, and divide by, this is going to be the standard deviation from the sampling distribution. How did we get the standard deviation from the sampling distribution yesterday? What did we have to do?
Standard deviation divided by the square root of the sample.
Divided by the square root of the sample size. So this is going to be our z-score formula. We're still going to be using NCDF, where we feed it left z-score and right z-score to get the probability or the area. So we will jump right into an example. Okay, what we know about this population is that the mean time spent reading the newspaper is 33 minutes. With standard deviation equal to 4 minutes. You are going to take a sample of 35 people from this population. Can you find the probability that the mean time spent reading is between 30 and 34 minutes? Okay. That's a lot to write. I try to break it down, but not right. Oh,
I didn't make it to the back.
oh, you gotta go.
Yeah.
Okay,
You just.
I'll put it right here. Okay, so I want to make a sketch of the population. Do I know what shape the population has? Did anywhere in here, did I tell you it was normally distributed? No, I did not. So I have no idea what shape the population that I'm drawing from has. So, make it look like coral again. I don't know. Okay. There's the population. I don't know what it is. It could be normal, but they didn't tell me. I'm not going to make it normal. But I know that the average time is 33 minutes. And the standard deviation is 4 minutes. Now, what this problem is saying is I'm going to pick 35 people out of this population. And I want to know, and I'm going to average the time they spent reading. So I'm going to ask all 35 people how much time they spent reading the newspaper each day. So now, what did we learn yesterday if I take more than 30 people from any population? What happens to that distribution? It gets normally distributed. Because I'm at 35, so I'm good. So if my sample size is equal to 35, the distribution becomes normal. Sorry, I'm doing the best I can. What do we know about the mean of this new distribution that I'm creating?
Wait, why is it 35?
Okay,
Wait, why is it 35?
that's what I gave you.
Okay, so then how does it make it?
Because of the central limit theorem yesterday said if you were at least 30, it's going to be normally distributed. Again, that magic number, I don't know why, but we just go with it. I know that the average is 33. How do I calculate the standard deviation here? What do I have to do?
Divide it by square root of 35.
Yep, and we're just going to leave it like that ugliness right now. We're not going to do a decimal for it.
So why do you have to do that again?
Because that's what the central limit theorem says. That's just the rule
How do we know to use that?
from yesterday.
Is
I
it
don't know.
standard?
Like, when do we use it?
When I'm taking more than one.
Why is it 33 and not 4?
The mean is 33. The mean doesn't change.
No,
Oh, who told me 30? Oh, yeah, it is 4. 4. Who did that? Who fed me the wrong number?
That's probably good.
Okay.
But if it just, it says the standard deviation is 4.
Of the population.
Okay. That's where I'm confused.
Now I'm making a sampling distribution of just samples of 35. And what that's saying is, if I was to repeat this, if I asked 35 people, what's your average? And I repeat that thousands of times, the new distribution turns out like this. Okay? So not just one time, but thousands and thousands of times. If I keep taking 35 and averaging them, the distribution will look like this. So I'm working off of this graph, and I'm asking, what's the probability that my group of 35 people spends between 30 and 34 minutes? So I'm looking for, on this graph, the area from 30 to 34. Do I know exactly where they're at? No, but I know that 30 is below 33 and 34 is above. I'm looking for this area. So which function on the calculator is going to give me this area? NCDF is going to give me back an area. What do I have to feed NCDF? Z-scores. Take a look at the formula. The NCDF wants Z-scores. Is 30 a Z-score? No, that's an X value. It's a mean, actually. So we're going to use the formula I gave you at the top. It's the only formula we have to convert 30 into a Z-score, and then we got to convert 34 into a Z-score. So I've got to convert these two things into Z-scores.
Where is a Z-score on that graph? Like, just
Nowhere. It's the standard deviation. It's how many standard deviations below the mean is 30, because I don't know what this is. So if I was to figure out 4 divided by the square root of 35, which is, I can do it real quick. Clear. 4 divided by the square root of 35, 0.67. So every 0.67 minutes is 1 standard deviation. So this is quite a few standard deviations below the mean. We're going to find out here in a minute. So we want the z-score for 30. And I'm using this graph over here. So it's 30. What's the mean over here? 33. Divided by, and then it's this fraction here. 4 over the square root of 35. I would definitely pick up a calculator to do this so you've practiced. You need parentheses here. Where do you need parentheses?
After the 30 minus 33.
Okay, around the top. Any place else? And around this fraction in the bottom. Try it on your calculators. Trust me. You guys will mess this up. If you the first time you do it's on the test, which is what some people do, they get them all wrong. Seen it happen. You got a negative number, and you should, because we're below the mean.
Okay, good.
Ooh, okay.
Oh, and then under review, I need to know, are you free lunch?
A little bit. And your review was a lot like this.
Shorts, I'm
Very
already
much
done.
like this.
Shorts already finished.
What is it?
Negative 4.44. Assuming you round the second.
Yep. So my graph is bad. My 30 is way back here into the tail. But that's okay. It doesn't really matter.
Negative 4.44 rounded to the second place.
So negative 4.44. And now we've got to turn 34 into a z-score. And if you're clever, meaning use your second entry button, you can just go up and change your 30 to 34 without having to retype the entire line, because that's the only difference. 1.48.
Now we plug that in.
And now you go to NCDF.
What's that?
Small group? Robot?
19. We only have 19 here. No, we're only missing one.
TLC, that's all.
Yes, they need it. Let's go there.
Stats now? What do we do
We
with
are stats.
You know how I feel about stats. I use stats in my job. You know when you always ask, when am I going to use this in my work? I use algebra.
That's awful.
That's awful.
What if you want to be a writer?
You're gonna write?
Yes.
But I'm just
From what
asking.
I've
No,
heard
I'm not.
from Fifth Hour,
Be a lawyer.
What does it mean again?
A lawyer?
I've heard stories
You think
of
I should
what
be a
to say
lawyer?
about
Oh, do I talk about you guys in fifth hour? I wouldn't do that.
You could say I kind of know all the services first in fifth hour, and
Everybody talks about it.
No.
The English majors are very good lawyers because they can write well. Biggest obstacle for lawyer work is not the oral communication, it's the written. So a
I
lot
feel
of
like
them
I'd be
are
a
now
really
becoming
bad
English
lawyer.
majors. No, pre-law is kind of an old school thing now. What they're doing is folks are becoming English majors, going on through law school from there.
you can argue a case.
You can
Michaela.
argue a case, but you gotta be able to communicate the written word.
That's what my.
No.
Oh,
So
you're.
that's what his
That's
paralegal
what
Yeah.
for.
legal assistant is for.
Bingo.
Alright. We can do that.
Okay.
Study the third lawyers and
I feel like you'd be a
Now, when you make it big, don't forget us little people.
That's right. Yeah, throw a little love back this way.
Or like a defense attorney.
Yeah.
Teacher in
Yeah, exactly.
the state of Michigan. It's not the
We'll go there.
I'll remember class.
Do you remember Mrs. Fix, Sue? Hook her up and release a new book?
Of course.
Yeah.
Maybe even two.
Okay, did you guys kick it into NCDF here?
I was just about to.
Yeah.
I'd be a terrible lawyer.
And this should have been quite a high probability because of this z-score being actually way, way back here into the tail. And this one's out way about here, out to 2 almost. I mean, you don't have to read it, but that's actually what we found there. All right, let's practice this so that you get the process down at least. Yep. Same.
Is this the last one?
Yep. Okay. Let's see, average home price, average,
Is this gonna be like a paragraph like the other?
mm-hmm. This is the selling price. Average home price is $125,700. This is back from 1997. It was across the entire United States, so that's including your low all the way to your high end, but that's the average back in 1997. Wish we had better data, but that's all I can go with. Okay. The sales prices are normally distributed. Now, so that's all the information about your population that you're going to take from. Okay, it won't tell you that, but you have to understand that this is referring to the population. You are going to take a sample of 16 homes and average the selling prices together. So you're going to take all different 16 prices, average them together so you have one number. I would like you to find the probability that the average selling price is less than $120,000. Nope. Okay, I like to make the population distribution and then the sampling distribution that we're actually going to do the probability of when you're ready. Oh, I didn't give you your standard deviation. Where is it? Oh, standard deviation up here. Standard deviation is $26,000. You always have to know those two pieces of information. So, my population is normally distributed. Average is 125. And the standard deviation is 26,000.
I know.
So we are going to take a sample of 16. Am I allowed to just take 16 and do statistics with this number?
No.
Why? Yeah. Because it's normal in the first place. Remember the two-prong central limit theorem? If the population starts out normal, you don't have to hit that magic number of 30. It's okay to be smaller. And you know that the sampling distribution is still normal, but narrower.
What did you say about the hitting 30?
If the population's normal, you don't have to hit the magic number of 30.
What does that mean, though? The population is normal.
That it has this distribution versus the stuff that looks like coral.
So how do you know that it's normal? If it's
You have to be told. If it doesn't say it's normal, you cannot assume it's normal.
Anything really normal?
Yeah, we are really normal. We'll go with
I
it.
thought I said, oh, never mind.
Is
I thought
that
that's
supposed to be thinner?
Yes.
What about when you're drinking?
So, here we go. We've got a mean. What's my mean of this new distribution? Same. 125.
12.57.
I'm going with that. How do I get the standard deviation over here that's making it a narrower graph? I'm going to take this standard deviation of 26,000 and do what to it?
Divided by the square root of 16.
Divide by the square root of 16. Okay. So my probability question is off of this sampling distribution graph over here. I'm looking for finding the probability that the average selling price is less than 120,000. So where's 120,000 on my number line? somewhere back here. How far? I don't know. It's just back here.
Wait, why didn't we use the same formula,
I'm not doing anything different yet.
for standard deviation? That's not the same formula we used the last problem.
Yes, it is. After I fixed it.
So, the 120 you just throw in there random, right?
Because that's in the question.
Yeah.
Yep. And I know it's below 125, so I don't know how far back to put it. And we're going less than that, so I need back here. So one of my z-scores is ready to have. What's my one z-score I know I'm going to be using? Because of the way this is shaded. What's my z-score back here?
Negative standard
Negative 10
deviation.
to the 10th.
Because you were probably talking
Actually, I've been quiet this.
when I switched this number to a 4. Did you catch that switch?
Yeah, I have it on my laptop.
Well, then how is this different than this?
Why is it the square root of 16? Does that simplify the square root of 16 or something?
Because I took 35 here, and I took 16 here.
Give a road, man.
So why is there a 4 over the 35?
Because that's the standard deviation here, and the sample size. The formula says standard deviation and sample size. So standard deviation and sample size, same format.
It gives you.
I don't know.
It's the standard deviation divided by the square root of the sample size.
Yep. Okay. Now, so the left z-score is negative 10 to the 10th. I've got my left z-score set. This 120,000 is an x value. We need to turn it into a z-score. So the z-score for 120,000 is 120,000 minus the mean 125,000 divided by this new standard deviation 26,000 over the square root of 16. Well, I could just put a 4 there. You okay with that? Without losing anybody?
Yeah.
And then just don't forget your parentheses. You need them around the top and you need them around the bottom.
Oh, that's what I thought we were already doing.
Well, and then after that we jump into NCDF and we'll be done.
It's not the square root of anything on the bottom?
Well, the square root of 16 is 4. I just thought I'd
Oh,
make it
so you already
easier.
did that, okay.
Yeah, that one I could do in my head. The other one I couldn't, so.
I got like
Negative .05.
I got negative 0.8.
Gosh, let's see who's right.
Yeah, I got that.
120, 123, minus 125, 700. Divide 26. Nice try, Austin.
Thank you. Nice try.
8 it will be. Yeah, so you should always be practicing with the calculator. Now where do I go from here to find that area? NCDF. NCDF. What's the left edge of my shaded region? Negative 10 to the 10th. And the right? Negative 0.88. And that will get you the probability. Oops, negative 0.88. I got 0.1894. I think we should try one more.
Is there more notice?
I'm going to start section 5. I'm not going to get very far, but just a little bit. One little skill that we're going to be using in 5. It's called a correction for continuity. You'll get it. Can I get rid of this? Well, I think we should do one more of these. Let's see if you can move through a little quicker. No? You're good? Are you sure you got this?
We should do it. I think we should do it.
I think we should too.
Have to be the person, but
I think we should too. I think we should try one more and just see how I won't guide you. I'll see if you can start it out all on your own. Okay. Oh, they probably don't even sell stereos anymore. Prices for home stereos
That's such a weird word.
are normally distributed with a mean equal to $625 and standard deviation 150. You are going to sample 10 stereos. Find the probability that your sample, so you find the sample that the average of the 10 is over $700. No guidance this time. You tell me what to start doing when you're ready.
The normal hump.
The normal hump. Because you see the word normal up here in the population, we'll go with that. Okay, what else? I would definitely put the mean.
And then the equal thing,
And then the standard deviation
with that, yeah.
being 150. If you want to put the mean here, you can, but, okay.
And then the arrow thing.
Then the arrow. Yep, so with n equals 10, what kind of distribution am I going to get? It's going to be normal also, because the population is normal. Because the standard deviation gets divided by the square root of sample size, so it makes the standard deviation smaller. And remember, anytime the standard deviation is smaller, everything's closer together. A big standard deviation is spread out, small, it's compacted. And what's my...
If the first one didn't start out as normally distributed, then...
This has to be at least 30 then.
Yeah,
Okay.
okay.
If it was not normal and this said 10, you'd say, can't do, not enough information. I don't think they give you any of those. They should give you one just to
They should.
see if you can catch it. So the mean here is
625.
625. The standard deviation here is
105 divided by the square root of 10.
150 divided by the square root of 10. You said 105. A little dyslexic there.
Yeah.
Okay. Well, that's okay. And then, now what? Mark the 700 over here. Somewhere over here it's above 700. And then I usually shade. Which way should I shade? To the right. Very good. Now what? For what number? 700. Use parentheses. Should be positive.
1.58.
Do we agree with 1.58? All right, now where? NCDF.
1.58.
And then 10 to the 10th is the other one that we didn't really have to calculate because we could see the shading went all the way. You're good there? And what did this come out? Anybody crank through it? 0571. You can do these? All right, one little skill in for the next section so that we get that out of the way.
So we're starting 5.5.
We're going to start 5.5. although we're kind of short.
Oh, we should do it.
Just makes tomorrow longer. Which way do you want, which hour, I guess, which day do you want a longer day? Today or tomorrow? Tomorrow? Okay, and I can stop there then, and then it'll all fit in. Okay, so 5th hour we might get into that if they move a little quicker, but that's okay, it'll all work out in the end. It'll all come out in the wash. Let's see.
Yeah, 5th hour is the fast class.
They are a little faster.
We're the slow class. It takes them only half the time to do the notes.
Well, I won't know about half. I gotta come up with an assignment here. Yes. 5-4. Okay. 5-4. 5-4. See, we're down here, finding probabilities. Page. 231. 15 to 22. How's that? It's on 232 then.
Okay.